Express the complex number 5 plus 5i in polar coordinates in the form r cos theta plus I r sine theta. So this is very similar to graphing like a normal point in polar coordinate form to rectangular form. It's just now I have i's attached. Now, if you've never seen a complex number graphed, it's very similar to graphing a regular point. You have yourself your real axis, you have yourself your imaginary axis, and in this case, our real number is 5, so you would go right 5. Our imaginary number is 5i, so we would go up 5, and we'd end up with a dot that you get from going right and up 5. Now, I need to make that associate with something that is much more rectangular, okay, or much more polar, because this is rectangular. So this is what we do. If I want to find my r in both cases, you are going to label this a and b. R is going to be the square root of a squared plus b squared. Now, r represents the magnitude, the distance from 0, 0 to our dot. It would make sense that the distance from the magnitude to our dot is kind of done in a very Pythagorean theorem way, where you would kind of take this number squared plus that number squared equals like c squared, like the Pythagorean theorem. Well, this is basically the Pythagorean theorem. So if a is 5 and b is 5, we have the square root of 5 squared plus 5 squared, which is 25 plus 25, which is the square root of 50. And you know that 50 is 25 times 2, so you can rip out a 5 and you're left with 5 square root of 2. So that's my r. That's my r. What I need now is I need my theta. My theta represents this degree here. It would make sense that if I know that you are 5 and I know that you are 5, I'm going to use a trig function that deals with the adjacent and the opposite sides. That's tangent. So tangent theta is going to equal opposite over adjacent, or in this case, tangent theta, whatever that theta is going to equal b over a. So if tangent theta equals b over a, then theta equals the inverse tangent of b over a. So theta is the inverse tangent of 5 over 5, which is the inverse tangent of 1. And the inverse tangent of 1 is a perfect slope of positive 1, which is going to be pi over 4. So theta is pi over 4. Now that I know what r is and now that I know what theta is, I can say that my number in polar coordinate form is going to be 5 root 2 cos theta, which is pi over 4, plus 5 root 2, let me sneak the I right in there, sine pi over 4. Okay, so not the prettiest looking thing in the world, but it makes sense that that's what we get by using the information that we were given. Fun stuff.